So everything in life requires energy. Energy gives us the capacity to do work. A lot of the times we think about work as like literally moving something. So this could be pushing a door and that's closing, and that's the work you do. We do biological work, and when we do this, we do chemical reactions. And what we're moving in a chemical reaction is usually an electron. So we're moving the electron either closer or farther away from the nucleus, or we're shifting it from one molecule to another to create a reaction. There are a couple of different types of energy. Potential energy is contained inside of an object because of where it is or what it's structured like. So a lot of the times when an object is not moving, like this bicycle at the top of the hill, it has a high potential energy because its energy is stored in its location because it's at the top of the hill. As the bicycle moves forward and down, it's getting lower and lower, it's going to lose the potential energy. In chemistry, our potential energy is based on where our electrons are. So an electron that's farther away from the nucleus is going to have a higher potential energy because that negative electron wants to be closer to that positive protons. Kinetic energy is the energy of movement. So anytime something is moving, it's got kinetic energy. So while this bicyclist is moving down, it's using its kinetic energy. It's releasing that energy. Heat is a measure of the kinetic energy of molecules. So a typical molecule, remember, except for water, which is less dense as a solid, but a typical molecule is going to be closer together when it's cold. And as it gets heated up, those molecules are going to start to move faster and faster and faster. And they're going to start to spread apart and become less dense. And so that heat is that measurement of this motion of those molecules. A chemical reaction occurs whenever bonds are made or broken. So inside of a chemical reaction, we have two kind of things here. So we have the reactants, and then we usually draw a big arrow, and then we have the products. So if you think about the word products, the products is something you're producing. So here's a chemical reaction down here. We've got methane and oxygen. These are the reactants because these are going to react with each other, and they are going to produce carbon dioxide and water. So these are my products. All reactions are reversible. So every biological reaction that can go one way can go the other way. Typically in the body, our reactions exist in some kind of equilibrium. So an equilibrium can just mean that it's at a stable state. An equilibrium does not mean that I have the exact same amount of reactants as products. An equal state might be when there's 4 times reactants for every 1 product, that the reaction is equal, right? So it's usually just there's a stable ratio between reactants and products that results in an equilibrium state. So metabolism is every single reaction that happens inside of your body. You've probably heard metabolism used in terms of like weight loss or energy usage, or, oh, that person's got a fast metabolism. What a metabolism is actually just every single reaction. And if you think about it, the more reactions you have, the more energy is needed. So there are 2 different types of reactions the body can have: anabolic or catabolic. This is an anabolic reaction. So we're going to take small molecules and we're going to invest energy into it and build a larger complex structure. So typically an anabolic is for building things. A catabolic reaction is just the opposite. So catabolic is when we take a large organized structure and we're going to break it apart. I'm going to break off each of these bonds, and when I break a bond, it's going to release the energy that that bond was holding. And so a catabolic energy is going to release chemical energy into the body. We can also classify reactions as redox reactions. So I like to remember this little moniker. Leo the lion says grr. So our friend Leo, when he loses an electron, he is oxidized. So whenever a molecule loses an electron, it becomes oxidized. So when we talked about sodium and chlorine, which one lost an electron? Right? So the sodium loses an electron to chlorine, and so that one becomes oxidized. Grr. So Leo the lion says grr. When you gain an electron, you are reduced. So in this change, sodium lost an electron, but chlorine gained one. So chlorine is reduced. You can kind of see how these are always together. If something is oxidized, something else must also be reduced. So I'm always going to have a reduction and an oxidation. That's why we took the two words and combined them together to make the word redox, because you can't separate these. So in this example down here, we've got molecule A and molecule B. This just means they're neutral. They don't have a charge. Molecule A is going to give an electron to molecule B. So which molecule is oxidized? Which one loses the electron? Right, A. And then which molecule is reduced? Which one gains an electron? B. Take a moment and write out an example of a chemical reaction and identify what is the reactants and what are the products.